So we've talked about aerobic training. Now we're going to talk about resistance training. And admittedly, this is not in my wheelhouse as much as aerobic training is, but it's important, like as much as it pains me to say that. But it is obviously important, and a lot of you have interest in this. And so we're going to talk about the changes that occur with resistance training this week and anaerobic training. So to start off, we need to have some definitions. And then we're going to talk about how we measure anaerobic capacity, right? We talked about how we can measure aerobic capacity with a VO2 max test. So we're going to talk about how we can measure maximal anaerobic capacity. So to start off, we've got some training or some definitions. And so first is resistance training. And so this is just training that's designed to increase strength, power, muscular endurance. All right. When I think of resistance training, think of lifting weights, that sort of thing, obviously. And so anaerobic training is where we're doing activities where we're having to use max force production. Okay, so they don't last very long. You're relying on your ATP, PCR, you're relying on glycolysis. And so that's anaerobic training. All right. And so then we've got strength, and this is just how well a muscle is able to generate force, and power is just at what rate are you performing work. So the formula for it, like the physics definition or the physics formula for it, is just force times velocity. All right. And so force is just mass times distance. And so if we go mass times distance times velocity, that's also power. All right. So nice and easy. So now, how do we measure anaerobic power? Like, what's the gold standard? What's the best way to do it? Well, there isn't one. Okay. There's many different tests that are used, but it's still really hard to determine what is the aerobic capacity. And so there's three ways that we can do this. We've got the Wingate, we've got the critical power test, and we've got the maximal accumulated oxygen deficit. All right, so every one of you has done the Wingate, or in other words, the longest 30 seconds of your life. And so basically what the Wingate does is over those 30 seconds, you average the power output for those 30 seconds, and that gives you an idea of your anaerobic capacity. Okay? Then there's the critical power test. And so the critical power test is just what's the highest power that you can sustain for a few minutes. Okay? So 3, 4, 5, 6, 7, that sort of thing. Okay? And so exercise can be sustained if you reduce your power output. And eventually this reduction in power, like it says, is critical power. So let's just say we were to run several tests on you and we said, okay, we want you to cycle at 700 watts for as long as you can go. And so maybe you can go for a minute and a half. Okay, and then we do the same thing for 600. Maybe you go a little bit longer, 500, so on. Eventually you're going to reach this point where it's like, okay, apparently at about 350, I can sustain that for quite a while. That would be your critical power. Okay, again, it's not easy to measure. And in terms of running, so a 10K pace is close to critical power. Well, the problem is many people that do anaerobic and resistance training, you guys don't run 10Ks, right? You go lift weights. And so it's a little bit more difficult to determine. Where I can tell you what my 10K pace is, it's about 7 minute, 15 second miles. At least I hope it is. It's probably a little slower. But I would be willing to bet that I ask most of you, and unless you're on the cross-country team, you probably don't know. And then the last one is the maximal accumulated oxygen deficit. All right, and so this is the difference between your predicted oxygen demand and how much oxygen you're using during what we call a supramaximal exhaustive test. Okay, and so it's really hard to measure. All right, and so first of all, you got to figure out what someone's VO2 max is, and then you do several. Depending on the protocol, you do several sub-maximal bouts, ranging anywhere from 30 to 90% of max, and then you do a supra-maximal bout at 110% of VO2. Okay, and remember, you can be at an intensity that's greater than what elicits your VO2 max because you're relying on these glycolytic systems. Okay, and so if you find out that on the bike you hit VO2 max at 300 watts. Well, then you can bump that up to 330 for your 110%. All right. And so you have to use some math and some statistics and that sort of thing to try and figure out what the maximal accumulated oxygen deficit is. Okay, so a way to think about that is you, you basically plot your line. Remember, I don't have a figure here. We'll talk about this in class, but you've got your graph here, and so this is intensity, this is VO2. Okay, and so your line's going to look something like this, and let's say this is where you hit max. Well, then you're going to run another test at 110%. You're going to see where you're at. Maybe at 110, your VO2 is, just whatever it is right here. Well, based on the prediction, you should actually be up here, kind of thing. That line should be straighter. And so we say this is your oxygen deficit. Okay, and so we'll discuss this in a little more detail in class to help it make sense, but at least want to give you the idea of what kind of methods we've got to measure anaerobic capacity.